you're looking at these in the lab activity today. This is large gravel, and it's, you know, pea size frequently is what they call it. Then you can have fine gravel, which is smaller. You can have sand. All right? These particles start to make soil. These will break up over time, and you'll be left with sand, and you'll be left with silt, much more fine. See that? And you'll be left with clays, which are very small, and they're very slimy when they get wet. You're going to be sorting them by texture. I'm going to show you one way that we will be doing sorting by size, and this is with a sieve system. All right, and we have different grades of where the particles would go through. So that's large, medium, smaller for sand, it's a grit 60, and then a grit 230. And that grit is the same kind of grit as on sandpaper. And then the last tray would be collecting our fine clays. So what you do is you'll take your mixed sediment, where we've got sand, gravel, clay, and silt and clay all together, and you'll pour it through. And then you just shake it and it goes through. This is just like those toys when you're a little baby and you had the little rain stick toy. All right, and you would just shake it and you would turn your toy and the beads would go through, and different size beads would stop at different layers. Exactly the same thing, it's just it's not a toy. So we'll sort each layer, and it's going through this column and sorting it by particle size. That might be enough. So then we see on the top layer the large gravel. So now this is all the large gravel. This was a grit of 5, so that's really coarse. Then we have the grit of 10, which is small gravel, fine gravel. And that's much more what you might see in like an aquarium. All right, so smaller than pea sizes. Then we get to now what we start talking about in our soils for agriculture and construction. This is sand, and this is becoming a coarse sand, really. And the more we shake it, we can get more out. I'm going to show you the second layer. But this is a lot of sand. It's actually from our volleyball courts out at campus, and that's a nice, it's a coarse sand. It's not. What a geologist would then do is they would measure by weight each layer of sediment, and then they could tell you by weight the different compositions in your soil. So now you see this very fine sand right here. Can you see that in the lid? Probably not. It's just like a nice little powder. Like it feels almost like a powdered sugar. That's silt. So it's very, very fine and very smooth. Then in this very last tray, what it didn't look like there was going to be hardly anything, we get the clays. And the clay just looks like very fine dust. It's just super powdery. See that? So these are clays that are coming out of the soil when we sift it through the screens. All right? So a farmer is going to start to use something more like the settling tubes with water. And they'll take their soil. This is a nice soil. We actually got this soil out at the Santa Margarita Ecological Reserve Overlook Station. So this is a very beautiful California soil. And what you'll do is you take your settling tube. In class, we would use test tubes. In the Nearpod, you're using jars. Anything that you can get a nice straight side on. Now, we've got the professional set here. You see the narrow tip. This is to help get your particles more visible, especially if we're doing a lot of fine clay. So this one is calibrated for this narrow tip. To add a little bit of your soil, you want to make sure it's broken up really fine, no chunks. And so you just crush them up with your fingers. And then you put, it's a rough estimate, about 20%, kind of a ratio of 5-to-1 soil to water. And we're going to be dissolving this, well, the soil doesn't dissolve, the nutrients will dissolve. You put it in with water. And then this will settle, and with settling rates, the larger particles, which will be heavier and more dense, will sink first. And then that's going to be sand. The second layer to sink over time will be the silt. And finally, the smallest particles to settle out will be the clays. They'll settle overnight really slow. It can take 24 hours. And there we go. They will fall down on the top. So then we'll see a nice layered system when we come back tomorrow. And right now it just looks like muddy water. And then overnight it will look different. I'm going to do a couple different ones so that you can see the different color. This is the soil from Santa Margarita Ecological Reserve. This is a soil that my student Justin brought us, and I think he said this was Central Valley. So he brought this from agricultural trip to Central Valley. So we'll just compare those two soils, and then I'll show you a basic sand. With your sand, silt, and clay, that changes how the water is going to move through the soil, and that changes how your nutrients will be able to stay in the soil or leave. It'll also help us to do a chemical testing later, because into this water it's going to dissolve the nitrogen, the phosphorus, and the potassium. Any mineral that you want to test, those are the big three we'll be testing for. I'm going to do one more for you, and that'll be our volleyball sand. You can see this one much more rapidly. See how quickly the sand settles, and see how that water's almost clear. There's virtually no silt and clay in this. Okay, this is going to be sediment sorting by settling. Sediment sort by settling. And so tomorrow we'll measure the height of the sand, silt, and clay in each of these tubes, just like you have in the Nearpod activity. All right.